Okay, so here in the first problem, you've got car A, and car A is traveling along at north 12.5 meters per second. So we're going to put car A traveling north. So we'll insert the information for MA and VA. VA is 12.5 meters per second, and the mass of that car is 1,050 kilograms. The other vehicle that you have is traveling east. So car B traveling east, and they're going to collide. So I'm going to put MB and VB here. So the mass is 1,200 for the second car, slightly more massive, and the velocity is only 9 meters per second, so it's certainly less. After the collision, the two of them are stuck together. So B and A jammed together, and obviously with one coming in east and the other coming in north, they're going to go careening off in some direction up here. We don't exactly know where. Okay, so we don't know what the after momentum is going to be. The question wants to know what is the speed going to be of these two objects afterwards, and what's that direction going to be. Okay, that's going to be what we're searching for. Okay, so to solve this, we need to go with not just the momentum before equals the momentum after, but what we've learned is that this is also true in each direction. So all of the x before equals all of the x after, and all of the y momenta before equals all of the y momentum afterwards. Okay, so in each direction, you know it's conserved. So I can work out, I can use MA and VA before. This is going to be my total momentum in the y direction for PA. So if I take that, you're doing mass times velocity. So you have your 1050 kilograms. You're multiplying that by 12.5 meters per second. And that gives me a momentum of 13,125 kilogram meters per second. So this is the entire momentum in the y direction, because it's moving north. I'm going to work out the momentum for B. It's moving in the east direction, so it's going to be all of the x. So my PB for object B is going to be the 1,200 kilograms multiplied by 9.0 meters per second, and that's going to give me 10,800 kilogram meters per second. And this momentum B is entirely in the y, or the x direction, excuse me. So this is my total x before. And what we know is that your total x before equals your total x after. So there's only one momentum in the x direction before, so that entire 10,800 is the momentum in the x direction afterwards. 10,800 kilogram meter per second. And we know that the entire y before equals the entire y afterwards. So the y component for both cars is 13,125 kilogram meter per second. So if you know the total x and total y, we can get the resultant momentum for the cars by using Pythagoras theorem. So we know that r squared equals 13,125 squared and 10,800 squared. Drop in the units because I don't have much room. You take the square root of that answer, and when you're done, you get the total momentum of this object, which comes out to like 16,999, so we'll round that off to 17,000 kilogram meters per second. And then we can get our angle by taking the inverse tangent of the opposite side over the adjacent side. So 13,125 divide by 10,800, and that gives me an angle of about 51 degrees. So that direction then is going to be east, because I drew it first, 51 degrees north. If you drew your triangle different, then you might have north 37 east, and that is or 39, I mean, north 39 east, and that is okay if you'd have drawn it slightly different. Now, just before I walk away from the question, it did not ask me the momentum afterwards. It asked me for the speed. So this kilogram meter per second is not a speed, that's a momentum. So we need to take one last step and divide that by the mass of both objects to get V prime. You take P prime and divide by M. So the P prime is 17,000 kilogram meters per second. We will then divide by the total mass, and the total mass of the objects is 2,250 kilograms, and you are going to get a resultant velocity of about 7.6 meters per second, and the direction is exactly the same as the direction of the momentum. So there's our first problem solved. The second problem is going to be just a little bit different. So the second one is a car A is now traveling west. So we've got car A, it's going west. Better move them over here. Going west. So the mass of A is 950 kilograms, and the velocity for A is 16.5 meters per second. And then car B is traveling south, so from the north, traveling south. Here's object B, so MB is 1125 kilograms, and VB is 13 meters per second. And they are going to then hit and collide, but they don't stick together this time. After the collision, car A comes to a complete stop, so VA prime equals 0, and car B, after the collision, goes tearing off in this direction. So VB prime is unknown, as is the angle of its travel, also unknown. We assume that they didn't lose any parts in the collision, so 950 kilograms after, and 1125 kilograms afterwards. And now we're ready to try and solve the question. So again, to find the momentum of B, we need to work out all of the x's before, and then we can translate that to be all the x's afterwards. So all my x's before are these ones here, because they're in the x direction. So I can get PA initially. It is 950 kilograms times the 16.5 meters per second. And so my initial momentum in the A direction is like 15,675 kilogram meters per second. We'll do the same for object B. So this, by the way, the A, this number right here, is my x momentum. It's all the x direction. My B, you're going to get mass of B, which is 1125 kilograms, times the 13 meters per second. So my momentum in the B direction is 14,625 kilogram meters per second. And this is the total momentum in the y direction. So now my total x before equals my total x after. Object A doesn't have any momentum, so it's all transferred to object B. So object B gets the entire 15,000 675 kilogram meters per second. And the downward part of this, that momentum, if I just move it over here for a second, I can't move it over. So that downward momentum, I'll just draw an arrow over to it. This side of the triangle is going to be exactly 14,625 kilogram meters per second to get this, and we still need to get R. So the R is, again, Pythagoras like the last question, of 14,625 squared and 15,675 squared, and take the square root, plug that into your calculator. I think you get 21,438 kilogram meters per second. That is the entire momentum for object B. So that is PB prime. Kilogram meter per second. Question was asking, what is VB prime, which means you take the momentum and divide by the mass. This time it's only mass B, not the total. So you're taking your 21,438 kilogram meters per second, dividing that by the mass of B, which was 1125 kilograms. And when we divide that, you get about 19 meters per second. So pretty fast moving after the collision. Looks like they're going about 68 meters per second or so. Really quite fast after the collision. I need to have a direction because right now that's a speed. So my angle that I have up here at the beginning. So if you remember, your triangle had sides of 14,625, and this side that was 15,675. We work out the angle. Okay, so to get that angle, you're going to do inverse tan of the opposite side, 15,675, over the adjacent, which is 14,625, and that gives me an angle of 47 degrees. The way I've drawn my triangle then, the direction would be south first, then 47 degrees east. If you drew this the other way and you're curious, you would have had, and I said east, but that's west, sorry. If you drew it the other way, it would have been west, 53 degrees south. Okay, so we've got our second one worked out. The third one is actually even harder than what we've seen so far because it's not giving you mass A. So this one's going to be tricky. So we have car A, and it is traveling from the north, so it's traveling south. MA we don't know, and VA we do know to be 10 meters per second. So there's my before information for A. My before information for B is the mass of B is 1,100 kilograms. The speed for B is 14.5 meters per second. And those two come in and collide. They stick together, A and B. They move off at this here, and we are told in the question that together they move off at 9 meters per second. So we're given the velocity. We are given the angle that it went south and then east 58 degrees. So we know that angle's 58 degrees. And the combined mass afterwards is going to be the mass of B, 1,100 kilograms, plus the mass of A, which I don't know. Now, to solve this question, I'm going to state basically the momentum in the x direction before is equal to the momentum of the x direction afterwards. So the px before is equal to mb times vb. So that's equal to 1100 times 14 and a half. And when we multiply 1100 and 14 and a half, you get 15,950 kilogram meters per second. So that's what this side right here has to equal, this px prime afterwards. But I know that the px prime is going to be the momentum p prime times sine of 58. So I know that I could set up a formula that says that p prime, or that probably the best way to write it, is to say that that sine, I'll set up the equation, sine of 58 equals opposite, which is px prime, over hypotenuse, which is p prime. So px prime is also p prime times sine 58, because that just comes up and multiplies. Okay, so I don't know p prime. Well, p prime is just m times v prime. M is 1100 plus ma times v prime, which is 9. So that's 9900 plus 9 ma. So there's p prime. So that means my px prime is p prime, which is 9900 plus 9 ma times the sine of 58 degrees. And that has to equal the 15,950. Because the x before has to be equal to the x after. So now we have an algebra equation to work out. 15,950 equals 9900 plus 9 ma times the sine of 58 degrees. Well, if we're trying to solve for ma, we'll take the sine 58 to the other side and divide. And if you take 15,950 divided by sine 58, you get like 18,808. That equals 9,900 plus 9 ma. Again, trying to solve for ma. So take that 9,900 to the other side. So if you take 18,800 minus the 9,900 gives 8,908 equals to 9 times ma. Divide both sides by 9, and you get yourself that ma equals about 990 kilograms. Quite a tricky little question, all relying on the fact that we had to write what the x before was. The x before was the easiest of the calculations. We made it equal to the x after, and then we also wrote the x after a different way. So the x after is also its momentum times sine 58. Its momentum had an ma in it. We didn't know what it was, but it was just mass times velocity. And then we were able to set up an equation and solve for ma. Definitely a trickier question, and hopefully this sets you up for success in future questions.